Okay, we are starting with section 11.3 today. In this section, we are going to talk about solving quadratic equations using the quadratic formula. Now, the quadratic formula is basically derived from your quadratic equation in terms of, if you were trying to use this as completing the square sort of aspect, if you would try and do that with your quadratic equation here, you can actually come up with the quadratic formula, but that's not what we are going to do here. So what I want you to do is look at the quadratic formula here, and basically we are going to try and use this to help us solve the quadratic equations. Now, as we saw earlier, completing the square is a pretty tedious and time-consuming process, so that's why this formula will actually help us solve time and find our answers that you could have found by completing the square. So your quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac and the whole thing over 2a. Now that's important for you to remember that this whole thing, negative b and all the way to the square root, this whole thing is divided by 2a. So all you really have to do is to find what your x value can be, is look at your equation ax squared plus bx plus c, and your a, b, and c's are what these a, b, and c's in the formula are going to be. So you just take the formula and you basically substitute all your values into the formula. Now what we want to do is see how we can do that. So anytime you start working with the quadratic equation, remember to write your equation in the standard form. So again, it has to be in the ax squared plus bx plus c form, and then, as I said, identify your a, b, and c and substitute that into the formula. So let's go ahead and start with our first example. Okay, let's see here. We have x squared minus 4 equals 2x. So as you can see, this is not in the standard form. So the first thing we will do is write this formula in the standard form, and that will give us x squared. You'll bring your 2x over to this side, so that will give you minus 2x minus 4 equals 0. Okay, so all we did was move our 2x from our right hand side to the left hand side and write this in the standard form. Now you need to identify your a, b, and c. So your a coefficient is on the x squared term, so you can see you have just x squared, which means your a is 1. Your b coefficient is on the x term, so on x you can see you have a negative 2, so your b will be negative 2, and c of course is the constant term, so your c will be negative 4. Now anytime you have that negative sign, the minus sign, your coefficients will be negative. If this was x squared plus 2x plus 4, then your coefficients would have been positive numbers. So if it's negative or minus, you have to include the negative as part of your coefficients. Now let's see. We'll go ahead and substitute these into our quadratic equation now, or quadratic formula, and your formula is right here. Okay, negative b plus or minus square root of b squared minus 4ac and the whole thing over 2a. Now the reason you have that plus or minus in the middle of your formula is because, again, you can have a positive and a negative square root, and that's the reason why we include both answers in our formula. So now what we need to do is substitute our a, b, and c and see what we come up with. So you have x equals negative from your formula, okay, negative. Then your b is minus 2. Okay, so you should end up with two negative signs. Plus or minus, inside your radical, you have b squared. So b again is going to be -2. So square that, minus 4 times a is 1, times c is -4, and this whole thing is over 2 times a, and again a is 1. So all we do is for every variable a, b, and c, go ahead and substitute your coefficients that you identify here, and now we're ready to solve this. So let's see how to do that. Now you have negative times -2, so negative and negative become positive, and you end up with a +2, plus or minus. Inside the radical you have -2 squared, so -2 times -2 will give you a +4, and then you have 4 times 1, which is 4, and multiply that into -4, which will give you -16. Okay, so 4 times 1 times -4, this gives you -16, and then you have this minus sign here, so negative from here, and then the product of the three numbers gives you -16. So again, you should end up with 2 negative signs over there, and your denominator will of course be 2 from 2 times 1. Now we're ready to solve inside the radical. So you end up with 4 minus -16. Again, minus and minus become positive or plus, so you end up with 4 plus 16. Okay. So again, we're just carrying forward the 2 plus and minus till we're ready to work with them. And now we are looking at 4 plus 16, which is 20. The whole thing divided by 2. And now let's go ahead and simplify the radical square root of 20. And of course we know 20 is not a perfect square, so you will have to simplify it. And you can write 20 as, let's see, 4 times 5. 4 being a perfect square, you can bring it outside the radical. So we'll go ahead and write our 20 as 4 times 5. The whole thing over 2. So again, just carry over your 2 plus and minus. And now square root of 4 can come outside as 2. And you are left with square root of 5 inside the radical. And again, the whole thing divided by 2. Okay, now we need to try and see if we can simplify this any further. Okay, so we have x equals 2 plus or minus 2 square root of 5, and the whole thing divided by 2. Now on your numerator, you will see that you have 2 plus or minus 2 square root of 5. So if you just look at the terms on the numerator, okay, you have 2 and 2, which is common between the two terms. So you can actually pull that 2 outside as your greatest common factor. Okay, so if I take the 2 outside, that leaves me with 2 divided by 2, which is just 1. Your plus and minus in the middle. We took this 2 on the outside, so that means we're just left with square root of 5. And this whole thing over 2. And now once we pull that 2 outside as your greatest common factor, you're left with 2 times 1 plus or minus square root of 5. So you can actually cancel out this 2 and this 2. And you will be left with x equals 1 plus or minus square root of 5. Okay, which is the same thing as x equals 1 plus square root of 5, or x equals 1 minus square root of 5. Okay, that's the same thing what that symbol plus or minus means. So again, we will say that our solution set for this equation is going to be 1 plus or minus square root of 5. So if you want, you can write it as a combination, or you can write it as two separate answers. They're both acceptable. Okay, and again, if you want, go back and check your answers just to verify that these are the solutions of our original equation. Right, let's take a look at this example here. Okay, again, you can see this one is not in the standard form, so you will have to first write this in the standard form. You have r minus 3 times r plus 5, and the whole thing equals 2. So we need to first go ahead and FOIL our left hand side. Okay, so r times r will give you r square. Your middle term will be 5r minus 3r, which will give you 2, and 3 times 5, negative 3 times positive 5 will give you a negative 15, equals 2 on the other side. Okay, so we basically just FOILed our left hand side here, and now we will go ahead and bring our 2 over to this side. So we subtract 2 on both sides, and you will end up with r square plus 2r minus 17 equal 0. Now you can see this is in your standard form. Ax square plus bx plus c equals 0. Okay, now what do? Of course, we identify our a, b, and c. Again, a is the coefficient of the squared term, so again you have r square, so your coefficient is 1. Your b is the coefficient on the middle term, or the first degree term, which will be r. So again, you'll see this is a positive 2, so your coefficient is just going to be 2. And c, being the constant term, is negative 17. Okay, so again you do the same thing. Plug these back into the quadratic formula, which will be negative b plus or minus b square minus 4ac, and the whole thing over 2a. Okay, so go ahead and substitute your values in. You have negative b, this time is a positive 2, plus or minus, inside the radical you have b square, which will be 2 squared, minus 4a, a being 1, and c being negative 17. And put this thing over 2 times 1. Okay, and this will give us negative 2 plus or minus, right, because you just have that negative 2 from there. Now we'll go ahead and solve the radical. So you have 2 square, which will be 4, minus, and go ahead and multiply 4 times 1 times negative 17, and that will be a negative, let's see, will that be negative 68, and the whole thing over 2 times 1, which is 2. Right, go ahead and combine what's inside the radical. So this time you have 2 negatives which make a positive, so you go ahead and add the 4 into 68, and you will end up with 72. Okay, 4 plus 68 will give you 72. Right, now again, you want to go ahead and simplify your radical first before you can start solving this. So let's see how to do that. So again, 72 is not a perfect square, so you need to see what you can simplify that into. And you can write this as negative 2 plus or minus. You can write your 72 as 36 times 2, the whole thing over 2. Now we know 36 is a perfect square of 6, so square root of 36 will come outside as 6. The 2 will continue to stay inside the radical, and again divide the whole thing by 2. Now, just like we did in our earlier example, we want to try and do the same thing here. See what is common between the two terms on your numerator, and you will see that you have a 2 and a 6 here. So between the 2 and the 6, you can see that 2 is a common factor, so we can pull that 2 outside. So negative 2 divided by 2 will leave you with negative 1, plus or minus. 6 divided by 2 leaves you with 3, and of course the square root of 2 is left also, and this whole thing divided by 2. Okay, so again you will notice that this 2 and this 2 will cancel out, and you end up with x equals negative 1 plus or minus 3 square root of 2. Okay, which again of course means the same thing. You have x equals negative 1 plus 3 square root of 2, or negative 1 minus 3 square root of 2. So your solution set is going to be negative 1 plus or minus 3 square root of 2. And you can see from these examples that, it's much faster to work with the quadratic formula than it was to work with completing the square. Now let's go ahead and take a look at this example here, and this one will actually be an example where you will end up with imaginary numbers. So again, the first thing you want to do is go ahead and write this in the standard form. And of course your standard form will be, first thing to do is multiply that x inside the parentheses, and then bring the 2 to the left hand side so that you can end up with your ax squared plus bx plus c equals 0 form. So go ahead and distribute that x. 3x times x will give you 3x squared, and then x times 4 will give you 4x, okay, equals negative 2. And now we'll bring the negative 2 over to this side, so you add 2, and that will give us 3x squared plus 4x plus 2 equals 0. Okay, and now this is your standard form, so go ahead and identify your a, b, and c's. Your a will be 3 on the x squared term. Your b is on the x term, which will be 4. And your c is the constant term, which will be 2. Right, again, let's put this back into our quadratic formula. So this is your formula here. Okay, negative b plus or minus square root of b squared minus 4ac, and the whole thing over 2a. Now we're ready to substitute our a, b, and c. So let's go ahead and do that. Negative b will be negative 4 plus or minus b squared, which will be 4 squared, minus 4 times a, which is 3, times c, which is 2. And the whole thing over 2 times a, and of course a is 3 this time. Okay? Now let's go ahead and simplify everything. Negative 4 stays the same, plus or minus. Let's go ahead and solve inside the radical. 4 squared will be 4 times 4, which is 16. Minus, you need to multiply 4 times 3 times 2. So 4 3s are 12. 12 times 2 is 24. And for your denominator, 2 times 3 will give you 6. Okay, now again we'll go ahead and simplify inside the radical. So negative 4 plus or minus. What will 16 minus 24 give us? And you can see 24 is the larger number. You're subtracting a larger number from a smaller number, so you will end up with a negative answer. And 16 minus 24 will give you negative 8. And again, the whole thing over 6. So right there, since you end up with a negative inside the square root symbol, you know that you're going to end up with an imaginary answer here. Okay, so let's go ahead and see what do we do now. Now remember, again, you want to get rid of that negative inside the square root. So we'll go ahead and use our number I, and let's go ahead and see what happens next. Okay, so you have negative 4 plus or minus. Again, remember I equals square root of negative 1. So square root of negative 8 will become I, which is square root of negative 1. So we take the negative outside, and you're left with just a positive 8 now inside your radical. And don't forget to divide the whole thing by 6. Okay, now that we got rid of that negative sign by using the number I, we are ready to simplify square root of 8. So again, negative 4 plus or minus I. You can write 8 as 4 times 2, 4 being the perfect square. Divide the whole thing by 6. Okay, so you will end up with negative 4 plus or minus. Square root of 4 will come outside of your radical as 2. You're left with I, don't forget that I, and then square root of 2 will continue to stay inside the radical symbol. And then you divide everything by 6. Now you are ready to see if you can simplify this any further. So let's see, you can see that between your 4, negative 4, and the 2i square root of 2, between 4 and 2, you have 2 as a common factor. So let's go ahead and get that 2 outside. Negative 4 divided by 2 will give you negative 2, plus or minus. Again, 2 divided by 2 will be 1, so the 2 comes outside, so that leaves you only with I, square root of 2, and the whole thing over 6. Now, of course, 2 and 6 will not cancel each other out, but 2 can go into 6 3 times, so you can simplify it that way. And you will end up with x equals negative 2 plus or minus I square root of 2 and the whole thing over 3. Okay, so again, your solutions to x are negative 2 plus I square root of 2 over 3, or negative 2 minus I square root of 2 over 3. So your solution set in this case will be negative 2 plus or minus I square root of 2 and the whole thing over 3. Okay, so in this case, since our denominator did not cancel out completely, we ended up with our answer having a denominator in it. Okay, and that will be your solution to our equation here.